So let's look at the homework solutions. If I'm going too fast, you can always hit pause and slow this down if I get going too quickly. But this first problem, number 20, is a 4-term polynomial. The way we're going to factor those is by grouping. So I'm going to group the first two terms together. Whoops, if I can actually get this to be a writing utensil. There we go. So I'm going to group the first two terms together. So that's 8y cubed minus 4y squared. Now with the minus sign coming next, we have to go plus negative 50y plus 25 for the second term. Now we've grouped them. Now in each binomial, we're going to pull out the GCF. So between those two terms, the largest number that goes into them is 4y squared. So now the first term will be 2y, and the second term will just be a 1. In the second set of parentheses, the GCF is 25, but since the first term is negative, we're actually going to factor out, if I can make a plus sign there, we're actually going to factor out negative 25 so that the first term is positive 2y, and then the second term would be a minus 1. Now this is where the magic happens, because what's inside the grouping symbol there, 2y minus 1, is identical in both terms. So that's now a new common factor that is going to get undistributed or factored out. So that 2y minus 1 comes out. So what's left behind in the first term is this 4y squared. What's left in the second term is the minus 25. So that's factoring by grouping. On this problem, though, we're not quite done because the 4y minus 25 is a difference of two perfect squares. So that will follow the factoring pattern 2y plus 5 times 2y minus 5. Now it's completely factored. Okay. The next problem, 22, is very similar because it's also a 4-termed polynomial. So there's no GCF. So we're just going to group up the first two terms, 3p cubed minus 21p squared. And then the second term, because of the minus, we have to put plus negative p plus 7. In this first binomial, the GCF is 3p squared. So then what's left behind in this first term is just p minus, and then in that second term, 7. In the second binomial, there's really no GCF here, except the first term is negative, so we can factor out a negative 1, and then that would leave us with positive p and a minus 7 left behind. And just like on the previous problem, and this is what has to happen in factoring by grouping, is what's inside the grouping symbol is the same, so that's going to get undistributed out here. So p minus 7 comes on out, and then we're left behind here with 3p squared, and over here with that minus 1. Unlike the last problem, we're now done because none of those remaining terms factors anymore, because this is not a difference of squares, so it doesn't factor anymore. Number 24 is also a 4-termed polynomial, no GCF, so we group up the first two terms, 8z squared minus 4z, plus, we don't have to worry about that negative sign here, so plus, then open parentheses, 10z minus 5. GCF in the first term is 4z. After we take out the 4z, we're left with 2z minus 1. In the second term, the GCF here is 5. Take out the 5, we're left behind with 2z minus 1. Again, the 2z minus 1 is common to both terms, so we're going to undistribute that binomial. So the 2z minus 1 gets factored out. We're left behind in the first term with 4z, and in the second term with the plus 5. Okay? Moving along to the next ones, which don't exist unless switch that way. There we go. Okay. Now we're on a binomial. Binomials are different. Binomials only factor if they meet specific criteria. Now, number 26, no GCF. 25 happens to be 5 cubed. And z cubed is clearly z cubed. So what we have is a sum of cubes. So there's an algebraic definition that if you have a cubed plus b cubed, this will follow a special factoring pattern of a plus b times a squared minus ab plus b squared. So now we just plug in. This value of 5 is kind of like a, and this value of z is like b in the formula, or in the definition. So the factored form would be 5 plus z, and then 5 squared is 25 minus 5 times z plus z squared. And we're done. 28 is also a difference of perfect cubes once we notice there is a GCF in this problem. So we should first factor out that GCF of 3n squared. And then you're left behind with 8n plus 1. Now we have a difference of two perfect cubes because 2n cubed is 8n and 1 cubed is still 1. So we still have this 3n squared, and then we're going to follow the defined factoring pattern. So first term plus second term, so 2n plus 1, and then we have that a term squared. That whole thing squared is 4n squared, then a minus sign, and then this term times this term, which is 2n, and then plus this last term squared, and 1 squared is 1. So now we have that completely factored. Okay, number 30. It's a binomial, so it's got to be one of those special cases. Once we notice there's a GCF of 5 between those two terms, take out the 5, we're left with a difference of two perfect cubes, because 8 is 2 cubed, and t cubed is obviously t cubed. So we bring down the 5, and then we will follow the factoring pattern for a difference of two perfect cubes. 2 minus t, and then that first term squared, 2 squared is 4, plus the a term times the b term, 2 times t is 2t, plus the last term, which is t squared. And we're done. Okay, last one, last even one here is 34. We're back to a 4-termed polynomial, so we're going to go back to the factoring by grouping idea. 2x cubed plus x squared is our first group. We have that minus sign in front of the 72, so plus negative 72x minus 36. This first term, the GCF between those things is x squared, so we have 2x plus 1 left behind. In this second, the GCF is 36, but since the first term is negative, take out a negative 36. And that would leave us behind with 2x plus 1. Now what we have inside the parentheses is common, so that 2x plus 1 comes out in front, and then you're left behind here with x squared, and you're left behind here with minus 36. Hey, everything looks pretty good, except the x squared minus 36 is a difference of two perfect squares, so that will follow the factoring pattern for a difference of squares into x plus 6, x minus 6. Okay, good luck. Hope it made sense.